Thank you very much. Yeah, thanks for having me here. It's great to be here in Sofia again. As Christo already said, I work as a developer evangelist at Deutsche Telekom. Deutsche Telekom is one of the big telecom communication companies in Germany and in Europe. There, I work as a product owner runtime, so they basically just call me developer evangelist, so I can speak on conferences here, like here, but in real daily business, I work as a product owner for the runtime. I'll explain in a second what that is in our senses. It's a consumer IoT department, and we're actually based in Darmstadt, which is, yeah, hopefully nobody from Darmstadt is here in the room. It's in the suburbs of Frankfurt. My wife's going to kill me for that. So, what's IoT for us? As we learned from Brandon's keynote, it was an excellent keynote setting the frame for this talk here. There's an area which I would call industrial IoT, where you are really focused on solving specific problems in industry and manufacturing, where you are free to choose the best protocol for your tasks, the best devices that you can find. You focus on the highest quality that you need in order to succeed. You need to gather some data, control something. These are the major use cases there. However, we are working in consumer IoT, where the rules are a little bit different. We are not that much driven by choosing always the best technology or the best device, but we are driven by what the market has or what the market offers. If there's some cool device, like I really love that example, like the toaster burning picture into your toast every morning, and everybody wants to get that, and everybody wants to like make this toaster start burning the pictures when you get out of bed and you enter the bathroom, so it's ready when you enter your kitchen. These are the use cases that drive our business. So we have a huge variety of protocols to deal with. We have plenty of different vendors who invent really good, sometimes really good, creative solutions for connectivity, for security. Sometimes they're focused more on getting it as cheap as possible, as quickly as possible out to the market. But we still have to deal with those devices. And this whole market is very, very quickly evolving without us having a huge control into where it's going. Because, as I said, it's driven by the consumers, it's driven by the device manufacturers. Sorry, wrong way. So, as I said, we have to deal with lots and lots and lots of different vendors. So if you look at all those apps that they create, it's really great that they are there. They're specially focused on controlling and using their devices, but there's no interactivity at all. So what we're trying to do with our product is we bring them all together and make them interoperable. In the end, in an ideal world, there should be only one app, which is ours, which you should use, or which you should need to control all these devices and make them interact. As it was a joke, you can still use all the other apps, of course. It's your own decision. In any case, what we did, we built a little box, a gateway, an edge device that we sell to our customers that gets installed in their homes. This has different shapes, different varieties. There is an old one in the middle, the new one, more shiny one on the right hand, which is specially focused on supporting all those different protocols and make the devices connect to each other. We've started putting that into routers anyway, because our customers have routers at home anyway. So we put the smart home capabilities into these routers, so you don't need to have yet another device sitting in your living room. So what does it do? Brandon gave us a nice introduction in those edge devices already. So there's these, we are this gateway, which has supports lots of different protocols. Like we said, Wi-Fi, Bluetooth, these are the obvious ones. There are less popular or lesser known ones, which are pretty popular in the IoT world, especially in the consumer IoT world, are these like Zigbee, Z-Wave, Homematic in some countries, where you have all these capabilities of mesh networking, self-healing networks, which is really great. It brings its own challenges, of course. Then there are, and for the end user, there are, of course, apps to interact with all that, configure all that. They can connect directly to the device, or they connect via the cloud, so you can interact with your home when you're on the way. So these are the purposes that we fulfill with these gateways. Now, as we already talked about or heard about in Brandon's keynote, there are several challenges with this. For one, in the consumer IT market, we have the challenge that there are many, many different protocols that all of them have to be supported at the same time. So these gateways, these edge devices that we put into our customers' premises, they have to support them all. No matter if a certain protocol is best for this use case or if there would be another one which would have been better, it doesn't matter. These devices that the market demands are running on these protocols. There are weak areas of specification in all of these protocols, or they might be used in a very creative way to solve use cases that these protocols actually were not designed for. That makes it a little harder to implement communication with such devices. Also, these devices, all of them, might get some firmware updates, or they have firmwares running on them. Some of them need to be updated. Some of them might, when they get a new version, change their entire way of communication because the manufacturer decided there's a better way to do things. Which, if you are the one who want to communicate with such devices on a technical level, you have to keep that in mind, and you have to detect such API changes. Some devices get added additional capabilities with a certain new firmware version, or with a firmware version for a certain country, a certain market, which other firmware versions might not have. So if you're selling your product into all those markets, you have to deal with those varieties, although the device always claims it's the same one. But as Brandon already pointed out, in the consumer IoT market, we are in a market segment where price dictates what's possible and what's done. So many of those devices probably will never be updated, although they might have some flaws that need to be worked around. And last but not least is that device manufacturers, they're really good in creating these hardware pieces. Some of them, of course, have not the years of experience that we have here in software development. So they found creative ways how to design APIs. Or they figured it might be easiest to let the device communicate via the cloud directly, so you end up having a device communicating through your Wi-Fi router with the cloud. And if you want to control the device, you have to go through the same Wi-Fi router to the same cloud. So you have a double internet connection involved in there, which doesn't make it any more robust, it doesn't make it any more faster, and especially nobody cares about that. Consumers don't want to know those details. So, having these spoken about, or having talked a little bit about these challenges, there will be another talk right after this one in the Alpha Room about the challenge, or the survival guide of the challenges you have with interacting such devices. So I won't go into that many details right now here. But before we go on, I would like to share a couple of details about the restrictions that we have on such gateways. Because as you might already figured yourself, vendors of such devices, be telecom company like us or any other, of course we don't want to spend billions and billions on creating the most expensive, most capable hardware that we sell at an extremely cheap price. But we have to restrict ourselves in terms of how much RAM we put in there, how much flash memory, in the sense of hard disk, we can have there. Also about the processor architectures that we use. So we have a variety of ARM processors. We now added MIPS processors to that game, which brings their own challenges, of course. We have, on some devices, some gateways, we have a single core that we can use only. Some we can spend a dual core processing time, which makes it incredibly faster compared to the other one, of course. On some we run our stack natively. On some, especially on the routers, we're just embedded in as a virtual machine inside this router to guarantee that whatever happens in each of the other stacks won't have any side effects. But in any case, you can compare what we are running on and what we have to deal with. You can compare it basically to Raspberry Pi. However, to the whole family of Raspberry Pis, starting from Raspberry Pi 1 to 3B plus, whatever we currently have. So that's more or less what we have to deal with. And now let's have a quick look at what we put there on such a gateway, such a device. It is on core, it's running a Linux system. It's a very, very much stripped down Linux system. It only contains what's really, really needed. Some are more or less BusyBox based or something like that. Then we put on these small devices with such small restrictions, we would put the Java JVM. In order to make it fit at all, we reduce it to a compact profile 2, which reduces the Java footprint by about half. I'm not sure if you all know the compact profiles, because that's something, if you're not working in an area where you're restricted with such thing, you would never get the idea of dumping parts of the JVM, because the stuff that we throw away sometimes would have been useful to have, like JMX, for example. If you don't have JMX, it makes some things a little harder. We will look into that later on. On top of the JVM, we run an OSGI container. And inside this OSGI container, we put our application. Now, what can that be? If we have to start such a product, when we did start such a product, we thought about if there's anything out there in the market that we can use, because we're not keen on reinventing the wheel, of course. So one thing we found is a very large, very flourishing open source community around Java, a smart home in Java, basically. And this is the OpenHub community. So together with them, we started creating a project in the Eclipse Foundation. Eclipse basically is one of the largest independent foundations hosting open source development. And they currently have about 350 plus projects, not just a few of them related to the Eclipse IDE as you know it. But many, many of them are something completely different. They just use the Eclipse ecosystem as their home. They provide Git repositories, they provide build servers, and of course they provide a very business-friendly model to work with. They have a good license so you can use something commercially. They have a really good IP review process, so you can minimize the risks that working with open source or using open source can entail on the legal perspective, something that in daily business none of us really wants to deal with, but the bigger the company is that you're working for, the more important that stuff gets. So inside this Eclipse Foundation, we have created the Eclipse Smart Home project. We currently have a little more than 150 contributors, and really just a few of those are getting paid to work in their daily business on that stuff. The majority of that, even on the Eclipse Smart Home side, the majority of the contributors just does it in their free time, just for the sake of fun. And what we have then there is that, for example, OpenHub takes this smart home core that we develop in Eclipse Smart Home and turns it into an open source product, which is then called OpenHub. And what we do is basically the same. We use this Eclipse Smart Home core and use it in our commercial product. Not us, there are some other commercial vendors, and we all meet in this open source community. On one hand, this is really great. We'll have look into that. But what does it actually need? And what are the expectations when you compare an open source product for end users compared to an open source based product that you're going to sell on the market to somebody who's not that much involved in Java coding and technology at all, maybe? So what we're faced with is the open source world, where people have a really techy attitude. They want to do everything themselves. They want to hack that stuff. They want to change that stuff. They want to integrate new things in their homes into their smart home system. So they're really highly motivated to get things going at home, and they're really highly motivated to get involved themselves. However, if we want to sell a product that we put in a nice box, put it in the shelves in some stores, we are selling it there to people who pay money for that, so they expect it to work. They simply want to plug it in and it should work. They don't care for if that's a problem with the Zigbee protocol or if Wi-Fi is not stable enough. They bought those products, they bought their devices, and they just want to plug it together, not thinking about the technology, because not everybody understands it, and most of those people who pay for such products don't want to understand that. So we had to do something in addition to what we get from the open source project. We take those about almost 300,000 lines of code and add another 1 million lines to that, which is basically focusing on getting things smoothly, making them look nice, integrating the supported devices, very nice user experience with step-by-step tutorials. Also, the firmware management is one aspect that nobody really cares in the open source world. They just do it, if needed, directly. And they read the release notes themselves as well. So, on top of that, we added a smart home application. That's the one, or basically the back end for the mobile application, where it connects to. So we have the mobile client APIs in there. And then we have some teams who care for those mobile devices. But we'll look more into the left parts now, where this is what my teams are doing, and where we gathered some experience, especially with the interaction with the open source community. So what we do when we contribute to open source, or we develop some parts of open source, is that we invest, either having dedicated people to work in the community, foster the community, or contribute back our developments, which basically cost money. So what do we get back? Because when we invest in such an open source project, we first just lose something. And somebody else is profiting from it. So those open source projects, like OpenHub, they benefit from us being involved there. But on the other hand, there's something flowing back. We have an incredible amount of device support there. So there are more than 300 different vendor types of devices supported. And those device integrations, we call them bindings, they're developed by people in their free time. They come back for free. We can use them if we want to. Or we can adapt them to our needs if we want to, but we don't need to start from scratch. On the other hand, whatever change we do, and if we do something wrong, if we make mistakes, you can be sure that a couple of hours later, somebody is going to complain in some community forum saying, hey, guys, you broke some shit. What are you doing? So this is something that is really hard to achieve by just by doing that ourselves. This really, really incredibly fast feedback loop that we get by so many people actually using it productively. That's something you cannot, I cannot imagine how much you would need to pay to set up such a huge quality assurance department that actually uses this stuff themselves in their homes, in their own use cases all the time, and are so eager to update every couple of hours their system to get the latest and greatest features and giving feedback. This is something that flows back for free. We just have to read it, we just have to interact with them. But such a community is not built up by itself. Admittedly, there is a really high self-motivation of those people to get their homes, to realize cool use cases in their homes. But on the other hand, we really invest into leading the architecture decisions made in such open source project. We also try to guard the APIs, that they stay stable, that they don't break all the time. That is something, if somebody simply wants to make something work in their home, they don't care about long-term support of APIs. Some of them, or most of them, are not even professional developers. So they're really not aware of this problem. And that's something where we as professional developers have to take care of and have to assist the community with. Also, this project organization, legal paperwork that needs to be done together with Eclipse Foundation, that's something that's in our interest, of course, that doesn't happen by itself. Taking care for build release stuff, that's of course something you have to do in every project anyway. That doesn't really put any additional effort on us. Sometimes, before we want to add new features or something, of course we drive discussions there about how should we make it, how would it fit best for others. As I said, this is a melting pot with other commercial vendors as well, so we all have looks together at what makes sense for best sense for all of us. However, as I said, there are also floating back code to our product that might not be coming from professional software developers. So of course we have lots of unit tests, integration tests in this project already to make sure that the quality doesn't break, and you find the obvious things there, of course. We have these early for community feedback that we talked about, but of course you need other levels of defense against potential programming errors. Which means also, although you have an open source community, although you get early feedback from early adopters, of course you still need a professional QA department integrated in your development process. Of course you need beta testing. Of course we do some phased rollouts. It's the same like in any other development as well, like in web development. So not all customers are hit by the newest software release on these gateways at the same time. And of course, we do proactive monitoring as well. Let's have a quick look at our development process. What we did there is, because we're about 130 developers working on the same product, so we invented something like a synchronized, or not invented, but what we're doing is having synchronized Scrum or Kanban sprints, and every 3 weeks have a release train that every team with their latest features can join or cannot join. So we try under normal circumstances to have these fixed release dates. Whatever is ready will make it into that release train, into this release. And we called it this development aid approach because we have some part of these 3 weeks, we just do the feature development, and the other part then, the smaller part on the top, would be the stabilization phase where we put all that together, fix bugs that slip through, and then start the aid again, doing that on customer side, like starting with the beta phase, gathering feedback, fixing something if needed, before we roll that out to production. However, you cannot catch them all. I mean, there are many QAs here in the room. I see familiar faces here. Even if we all do our best, we all do a great job. There are things that slip through because you cannot see them at the phase of testing. You can see them only in real life. So we added, in addition to what we have from the open source world already, we had to add some additional lines of defense. For one, what is really helpful to have is remote logging. You might be laughing at, yeah, logging, of course, everybody does it. But our challenge is, as our customers do not want to know what is going on these boxes. They do not understand that. They don't read these logs themselves. So what we basically do at the end, it feels like we are running a data center with hundreds and thousands and millions of nodes distributed everywhere, having no access to them at all, which is not that easy to analyze if you're faced with some description of a problem. So what we can do is switch on remote logging to gather from individual gateways everything that they log. It's easy using some widespread stack like Elasticsearch, Kibana. I hope many of you know that already. So we can sit back in your office and read the logs from a gateway at the customer side. However, that deeply conflicts with data privacy, because in logs you see when somebody is at home, you can determine what he's doing by seeing when they're switching on lights, printing pictures on their toasters or whatever. Therefore, that's nothing you can do on a regular basis. You have to get the customer consent basically for that, to do that. And you have to do that very carefully. So we can do that all in our development landscapes, but as soon as something hits production, it must not log everything to the cloud again anymore. Also, what we can do when we are faced with a certain problem, we can gather everything that we need from like the whole context that the user was in. Using Sentry for that, it's also a very popular open source tool. It's mainly popular in front-end development. We can use it for the Java runtime parts as well. So whenever we have some points where we suspect that there's something can go wrong, we can collect the all the context that we need, or the database entries, and push that to the system, and thereby collect problems. Again, this is something we can do only in exceptional cases here, because we're conflicting with data privacy, and that's nothing our customers like. What we can do carefully in general is integrating our runtime basically health checks, that we check for certain conditions ourselves and report to our backend this condition is met or not met, which would mean all OCI bundles are started or not started as expected, or the system uptime, the JVM uptime, or something like that, so we can detect anomalies there. It's using low bandwidth, so there's no problem there. And we can really, it's really helpful for us to do something like that in order to do post-deployment health checks. Like we deployed a new release onto all gateways to all our customers, and a couple of hours later we can collect these health checks, analyze them, see if there's anything suspicious in there. Of course, it only works for things that we were anticipating that can go wrong. Other than that, we have no real good measure to see anything on a global scale, apart from doing active monitoring, of course. We can monitor certain KPIs on those gateways, and it makes it easier for when we are doing that for beta customers or something where they agreed on having such monitoring active, where we can quickly see anomalies like increasing memory size over time and then suddenly dropping memory because the gateway was restarted automatically then because the heap was exploding or something. So you see there things that you cannot see in active functional testing, but you can see them, you can monitor them while you're doing all these tests. You can monitor such gateways already, seeing if they behave normal or not, like CPU usage, for example. You can catch problems very early already. However, as I said, we cannot monitor everything on all gateways because we're not allowed to, or we don't want to breach data privacy there. Which leaves room for things going wrong. And if they can go wrong, they definitely will go wrong. So what can we do in such a case? Of course, somebody complains, calls our hotline, says, hey, guys, you delivered some problem here. How can we help this customer? We have put in some very, very simple thing which basically collects everything from such a gateway that is relevant to us. Every configuration, every log file, every native log file, every JVM crash report, everything that you could imagine. So we can take that offline, have a look at that. Again, as the user complained to that problem, we'll ask him for his consent. Is it okay if we collect those log files? But that doesn't give us always all the information that we need. One thing, of course, obviously, is to gather a heap dump to see what's in there, what's going on in memory. You can use Eclipse Memory Analyzer to look into there. That's something you would do in every other Java application as well. Just a little bit trickier to get that out of such a small gateway when it's so far away and you don't have access to that. So we put in a way to trigger that remotely and then upload it. So it helps us to analyze individual problems only. The other thing, really nice thing that if you don't know it, you should have a look at is the Java Flight Recorder. It's integrated in the Java Management Console. We can actually record the live behavior of the JVM. In Java 8, it was still licensed commercially only, so you had to have a commercial Java license in order to use that. I hope I'm not mistaken, I think they relaxed that rule with Java 9, if I'm not wrong. But don't trust me, check that yourself, please. But that's not all the whole story already. There's also another thing. Of course, the JVM uses native memory in the operating system, so it claims some area of the RAM, says, hey, that's mine, I'll use it for whatever reason. You can switch on native memory tracking in the JVM. It's just a startup parameter, or you can actually use it via JMix if you're lucky, but then for that you're out of luck in the compact profile too. So what you then get is a report about how much memory every technical component of the JVM claimed from an operating system and how much it returned. So you see how much how much memory the heap was using, how much memory the garbage collector was using, and all that. It's hard to understand all the details in there, but it gives you it quickly gives you a rough impression of if there's any misbehavior in the JVM or not. This is something normally on a Windows or Linux system you would hardly get into contact with. However, if you're running on a system with ARM or even MIPS, where there is not even an official, simply downloadable JVM available on the market, you're at a higher risk to face issues in there which nobody ever has seen before because nobody's using it in that way. So we have been there already and learned a lot from that. However, this native memory thing that I just talked about was something that the JVM reports itself. It doesn't tell us if the JVM behaves different than what it thinks it does. So what we did in the next for one analysis in the next step was to put something in between the JVM's memory allocation and the OS itself. It's called JEmalloc. It's a tool which or library which mimics the memory allocation of the glibc. Something you were hoping as a Java developer to never ever get into contact with. However, we had to, and it's really a nice experience and was a really great tool that I think it should. It's good to have that in mind if you ever need it. That's something where you can track really what the process is doing, how much memory it was, which part of the native library was allocating and releasing. However, one case that was even not enough because everything looked great and still our process ran out of memory. So what we then did, we really wanted to know what is in these memory blocks. What does this stupid process do? So one way of getting there would be simply read out the memory. However, Linux is not stupid. They don't let every process read out the memory of another process. But there's a trick to that. If you create a process that grows and grows and grows, the Linux system, or the memory management of Linux, is going to start swapping. It means it starts putting memory or content of memory out of the RAM into the swap, onto the disk, which makes it really, really slow. But the good thing is you can read from disks. So you can read the binary stuff from the disk, search for, and that's good that we have Java again, because Java is full of strings. So you can simply search for all strings in Java, sort them, count them, and see what's in there so many times. So we saw what was duplicated there. Something that when I started this project, or started working for this project, I never ever imagined we would have to do, simply because we tried to talk to some devices in customers' homes, written on software, written in Java, because that's all abstracted away, which is good most of the time. So when designing such gateways, it's always important to keep that in mind. And if thinking about taking the open source, it's really important to look at what does it need to, in addition of having such an open source project where everything is basically there. All the functions are there. Why don't you simply take it and put it on a box and ship it? Yes, that's why. So we are really happy with this interaction with the open source community. It's really beneficial for us. It helps us a lot. But turning the open source project into a nice and shiny product that you can sell, that you can put in a box for everybody to simply use it, takes lots of effort and additional things that nobody, especially not our customers, care about. Nobody wants to know that it just has to work, but this work is crucial to do. Otherwise, you will never ever be able to have, in this world of unstable, unpredictable devices, low-cost devices especially, you will never be able to have a product which gives you the feeling of a reliable user experience. And we are working hard on getting there. And I hope it was interesting for you to have a look at the toolbox that we have. I can really recommend, if you ever end up in working for the IoT world, having such a toolbox, such tools for analysis at your hands in order to analyze those issues that are left after all this testing and QA, because the issues that are sneaking through and that are left for you to analyze, those are the really weird ones that you never ever dreamed of facing. Thank you very much. Thanks for having me here.